In this lesson, I want to start to talk about domain modeling in Scala, and I'm going to use two resources. And the first one is this page that I co-wrote for the Scala Center. And the reason I'm looking at this page is because here I got into a little bit more detail than I do in my book, and you'll see why as we go along. But actually, what I want to do first is backtrack a little bit. So basically what happens is that all programmers around the world model the domain around us. So the domain could be a pizza store, or it could be a social network, or it could be something to do with automobiles. So this is what we mean by the word domain. It's the problem that we're working on, or the problem set that we're working on. And in both functional programming and object-oriented programming, one way or another, we model the world around us. And we do things a little bit differently in functional programming and object-oriented programming. And so that's why I kind of break things down the way I do, not only in this lesson, but some of the lessons that follow. So what I note here is that we probably, in a way, we may have started off with a construct like a class. And then as programmers went along, we found out, oh, it might be good if we had interfaces first. And then we had classes that implement those interfaces. So languages began to take on interfaces in addition to classes. And then these concepts just kind of kept growing. And I note here that because Scala has complete support for functional programming and object-oriented programming, it provides constructs for us to model these domains in both of these worlds. So now what I want to do is jump back to this page. And what we did here is we got pretty detailed in terms of these are the constructs that programmers can use to model the world around us. So we have these things called classes, we have objects, we have companion objects, which we'll get into. We also have this concept of traits. And traits can be used as pure interfaces with only abstract methods, but they can also have concrete members, so they can have concrete methods and concrete fields. And rather than having classes and objects extend traits, we say that traits are mixed in, and you'll see more about this as we go along. In my book, which I wrote only for Scala 3, I skip over abstract classes, and that's because these were more important in Scala 2 than they are in Scala 3. Traits are more powerful now in Scala 3 than they were before, and there's very rarely a need to use abstract classes, so I don't get into that in my book. I do cover enumerations in my book, and I'll show what they mean shortly. And I also cover case classes in my book. This is kind of a functional programming construct, and I did not cover case objects, but we'll come back here and talk about those in just a few moments. So getting back to my book, the first thing I do is I talk about object-oriented programming, domain modeling, and Scala support for those. So typically, when you're programming in an object-oriented programming style, you'll use these constructs. So you use traits, you use enumerations, classes, and objects. Those are the four primary ones. And when you're programming this style, you'll typically use traits as interfaces. And as I mentioned, traits in Scala are just like interfaces in Java 8 and newer. And what that means is that they can have not only abstract members, but also concrete members, where again, members are both methods and fields. We also use enumerations to model simple sets of constants. So that could be like the positions of a display, directions like north, south, east, west, could be the days and the weeks, the months and the year, that type of thing. And this is typically a small set, or at least a relatively small set of values like those that I mentioned. The other thing we do in object-oriented programming is we're primarily going to use plain classes, and we won't use case classes. Those are pretty much intended for functional programming. And another thing we do when we define classes in the OOP style is we'll define constructor parameters as var fields, and that's so that they can be mutated or updated over time. That's something we don't do in functional programming, but we do in object-oriented programming. And then we'll also contain methods that are based on these mutable fields, as I note right there. And then just like with other languages, we'll create getter and setter methods when programming in an OOP style. And in Scala, those are more often referred to as accessor and mutator methods rather than using the terms getter and setter, because we don't use terms like if you programmed in Java and you know that you always use get and set a lot. There are no standards like that in Scala. And in fact, those are typically discouraged. And finally, when we create objects, we'll primarily use them as a way to create the equivalent of static methods in Java. So in other lessons in this course, I've shown like a string utilities object, file utilities object, network utilities object, and those all contain what I call functions. And that's because we access them directly. They're not exactly the same as methods in a class. So we'll see what that means more as we go along. And the next thing I talk about is that Scala also provides complete tools for functional programming domain modeling. So here again, we're going to use traits and enums, and we'll use them in somewhat similar ways, and we'll see the differences as we go along. And then we also use case classes instead of classes, and then we use objects in a different way than we do in the OOP world. So when we use traits, we use them to create small, logically grouped units of behavior. And we typically write them in traits as def methods, and they'll also be implemented as pure functions. And one of the bigger differences here, and we do this in both worlds, but I think it's more common in functional programming, and we see that these traits are combined later into concrete objects. And so for me, at least, I think that's a bigger difference that I see, is that traits in the OOP style are used as interfaces for OOP style classes. And then in functional programming, I see them more used in this style. And I'll demonstrate that as we get into those lessons. And then the second thing is that when we use enums in functional programming, these are used to create something called algebraic data types. And you don't have to worry about that term too much. As I note right here, ADTs is the acronym right there. And they're actually a simple concept with this scary name right here. And actually, I found that I love to see my code as algebra. So this is actually kind of a complicated sounding term for something that's actually pretty simple. The next thing we do in a functional programming style is we use case classes to create objects with immutable fields. And this might be similar to other languages. I do know that there are immutable records in other languages, and I think this is somewhat similar to the record type in Java 14 and newer. But basically, case classes are like plain classes, but they have several additional standard methods that are baked into them that makes functional programming easier. And this is really cool, and you'll see what that means as we go along. And another thing that I don't really note here, I suppose I do note it right here, but it could be clearer, is that we don't use var fields with case classes. So when you use regular classes in an OOP programming style, your constructor parameters will be var fields, and then your fields inside the classes may also be var fields. And in case classes in functional programming, there is nothing that's mutable, so everything's going to be a val field, or the equivalent of a val field. And then finally, in functional programming, we're going to use objects in this way. There's this term that's called reification. Reification just means making something real. So what's going to happen here is we'll have some sort of object, and it will mix in a list of traits. And what that does is that this object that you create makes all these other ones real. And it makes them real if these are abstract methods over here. It makes them real by implementing those other abstract methods. And then FP developers work with those objects. And once again, I hate to keep putting everything off, but you'll see what that means as we get into that. And as I take another look over here, we will cover classes, objects, companion objects, traits. I will not cover abstract classes since they're so rarely used. We will cover enumerations. We'll cover case classes. And I don't know if we'll get into case objects. Let's scroll down here. Before we get into case objects, I need to mention one thing. So an object is basically just a class that has exactly one instance. So you can think that there's a little bit of magic going on in the system, that when you try to refer to an object, it actually only has one instance throughout your entire application. And I mentioned that string utilities object that I create, and this shows the Scala 2 style. We'll switch over to Scala 3 here. So this shows the syntax for Scala 3, and this shows these three functions that are defined inside of string utils right here. So these are three functions. And all you have to do is you import string utils, and you might say import string utils.star, or you might say import string utils.truncate, and then that would give you access to this truncate function, and then you can use that function inside your code. So again, inside of your application, there can only ever be one instance of this string utils object, and that's what the object keyword does for us. It manages that. How that works is shown here, and then the import part that I was mentioning is shown here. So you can say import string util.star, and then you can use those three functions like that, that, and that. So now we can look at case objects, and as this first line says, case objects are to objects what case classes are to classes. They provide a number of automatically generated methods that make them more powerful. And I haven't used case classes too much in a while, but they're actually terrific for passing immutable messages around, as I wrote here. So the way this works is you'll create something like a trait or a sealed trait like this one shows here. And so this one we call message. And then case classes implement these guys as shown right there. So these are three different types of messages that can be in your system. And you use these as classes here because they take in a constructor parameter like that. So these three are case classes. And then this one does not require a constructor parameter, so you create that one as a case object. And again, an object only has one instance throughout your entire application, so that's why we use it there. It doesn't have any constructor parameters, so you can just use it this way. So there's only one instance of this ever in your application. And the reason we define these as case classes and case objects is they provide some really cool behaviors by default. And one of those is that they work really well in match expressions. So what happens here is for your code to work as a match expression over here, it has to be able to be deconstructed. So you can say, well, I want to match on this thing called play song, and I want to extract the name out of that and then use the name over here on the right side of this transformation symbol. And for you to be able to extract name out of here and use it over here, in your code over here, there has to be something called an unapply method. So that's what this does for us, is a case class automatically generates an unapply method. And that unapply method is what makes this code down here work. So that's what I mean by these working really well for messages that you want to pass around in your system, is that they implement those behaviors, and then those behaviors work terrifically with pattern matching and specifically with deconstructing your class, so you can extract the fields out of a class with pattern matching and then use that field over here on the right side of that symbol.